Hello, students. So, now in this session, I'm going to be talking about ensemble learning. And the idea is very simple that you train multiple models and you combine their prediction. Basically, you have model 1, model 2, and all the way up to, let's say, model n, and you basically ask them to make prediction. Each one of the models, they make a prediction, and then you use the total prediction to figure out what the actual prediction is going to be. So think of this as instead of trusting a decision of one person, you are now trusting the decision of many people. So bagging, another name for that is a bootstrap aggregating. This is a type of ensemble learning. And the idea is this that you train many models independently of each other on different random samples of your data points. And then you average their prediction. So suppose these are your data points right here, and you have three models, model 1, model 2, and model 3. So you pick up one random sample from here, you feed it to the model 1, you pick up another random sample from here, you feed it to the model 2, and likewise you pick the third one and you feed it to model 3. So basically you're training these three models on three different random samples from this data points right here. So this is the general idea. You create multiple data sets using bootstrapping. Bootstrapping means you're sampling with replacement. In other words, you may actually end up using the same data point for different models. You train, step number two, you train a separate model on each data set. And then number three, you combine the prediction. If you're working with classification problem, you're going to take the majority vote. For example, this one predicts apple, this one predicts apple, and this one predicts banana. So the majority would be apple. That would be your majority vote. On the other hand, if you're working with regression problems, you're going to take the average. So let's say this predicted number one, this predicts number two, and this one makes a prediction as one. So the average of 1 plus 2 plus 1 divided by 3, and whatever the answer is, that's your average prediction right here. That's for regression model. So a very good example of your bagging is random forest. And the idea is very simple. Suppose you have this data set right here with only 4 data points. And suppose we want to create 3 models. So in this case, I'm going to create 3 random samples from 6 data points. And let's say I want to have only 4 features. So in this case, the first data set that I'm going to select would be 2, 4, 6, 2. If you notice, 2 is getting repeated twice, and that's okay. So in this case, I'm selecting this one, I'm selecting this record, 4, and I'm selecting record 6 right here. So this is getting selected twice. So this record is selected, this, and in the features, I'm selecting x2, x3, x4. That would be this feature, this feature, this feature. That would make my first random sample. Now let's move to the next random sample, the second one. In this case, I'm selecting, let's say 1, 5, 3, 5. That would be 1, 3, and 5, and then 5 twice over here. So I'm selecting these three records, and then I'm selecting these features, x1, x3, x4. That would be x1, x3, and x4 right here. Okay, and then likewise, I select the third one. So each one of these three random samples, they will be responsible for creating different models. And then step number two, now you build a decision tree from each sample. So each one of these bootstrap sample, they give you a decision tree. In other words, each decision tree is your model. So I have three models over here, one, two, and three. Step number three, now you generate predictions from all these models, from all these trees. So each decision tree will make its own prediction. Now, if you're dealing with the classification, it's going to give you a class label. On the other hand, if you're dealing with the regression, it's going to predict a numerical value. And then the step number four, you combine all predictions to form the final output. So for the case of classification, you're going to use the majority vote. In the case of regression, you're going to average the values out. So for example, in the case of regression, let's say this is number 2, this predicts number 3, and this predicts 2. You're going to take the average of 2 plus 3 plus 2, and that will be your answer. Now, the bootstrapping that was done in step 1 and the aggregation that was done in step 4, that is this step, this particular step, is called bagging. This is what the word bagging comes from. Now, one of the interesting key characteristics of bagging is that these models, they can be trained in parallel. And that's because each model is independent. The prediction coming from model 1 has no effect on model 2 or model 3. And likewise, the prediction that the model 2 is making, it has no effect on model 1 and model 3. So because of this, these things can be trained independently of each other. Another key characteristic is that they reduce overfitting. Now, the key idea is this: you can reduce variance by averaging noisy model. So let's understand this through this example. Suppose my actual value is 5. I'm making some type of prediction, and the actual value is supposed to be 5. And let's say the model 1 makes a prediction 4. So it makes a prediction that is under than 5. And let's say my model 2, it makes a prediction 6. So it makes a prediction that is over than 5. Now, when you take the average of model 1 and model 2, and the answer comes out to be 4 plus 6 divided by 2, and the answer comes out to be 5, which is very closer to the actual value. Now, the reason this one is very close to this is because this model 1, it made a prediction that was under, and this model 2 that made a prediction that was over. And the under and over, they kind of like cancel each other out, and because they cancel each other out, it kind of, this is basically what you mean by like averaging noisy model. So positive cancels with negative, so this way it reduces variance. So in this case, your prediction value will come out to be very close to your actual value.